What is up, guys? Fahir here from AwesomeDudes.com, and welcome to the complete C++ and Unreal Engine tutorial where we are, you and I, going to create a full game, a nice game to play using C++ and Unreal Engine. Yes, I said C++ because I'm only going to use C++, no blueprints, and we're going to create it from scratch right now. So let me just preview the game that we're going to create. Basically, this is based on the Battery Man tutorial that Unreal Engine did, but I perfected it. So just kidding. But anyways, you will see that we have these pickable items that are spawning and I can pick them up. The thing that is the bar that is going low that you see is basically my health. So I'm running and I'm trying to pick all of these up before the health drops to 0. What happens to me when the health drops to 0? Well, you will see in a moment. So let's wait and see what happens to the player when my health drops to 0. Bam, you see, he simply falls down and we restart the game. Even though it looks simple, it's really cool to create because I'm going to create everything from scratch. Even the movement of the character I'm going to create from scratch using C++. I'm going to spawn the pickable items, I'm going to detect collision, and I'm going to do all of this cool stuff. Everything using C++ because there is very little, almost none C++ tutorials using Unreal Engine. I want to fix that. So why am I talking? I know what to... Anyways, I know you're eager to start creating this game, so I'm going to jump right into it. But if you like this video, first of all, subscribe, comment, share, and like. But if you like this video and you learn a lot, consider enrolling in the Academy, my Ultimate Game Development Academy. Link will be in the description below because over there I also have a lot of C++ and Unreal Engine tutorials, which is going to be cool for you to learn, and it's also cheap to join. So click the link below and join after you watch this tutorial, of course. So let's get into the tutorial. I will see you right in a few moments. Take care. So now that we saw the game that we are going to create, let us jump right into it and create the game. So open your Unreal Engine and you will see the Unreal Engine project browser. Now we're not going to go here under blueprint. This is the one that by default that you will see. So you're going to click on C++ because we're going to create this completely in C++. Now I am going to use the assets that are available and come with Unreal Engine. So I'm going to click here on third person as you already see. And also make sure that here with starter content is selected because when you click on it, you can click here, no starter content or with. So make sure it is with starter content. Of course, over here, you're going to select the path where you're going to store the project. This is the name of your project, yada, yada, yada. You know the drill. Click on create and wait for Unreal Engine and C++ to compile and have mercy upon you. And then when you are done, this is what you will see. Now, if I hit the play button right now, we will see that we have a character, we can move, we can jump and all the good stuff. But I want to create this from scratch because I want to show you, I want to explain some things that are not explained over here because we have it pre-built, and I want you to learn a little bit about C++. And of course, I will learn along with you. So as I said, I do not want this third-person character, so I'm going to simply delete him, and instead I'm going to go here in my C++ classes, and here for the battery collector, this is the name of the project that I set, and over here I'm going to right click and create a new C++ class. It is going to inherit from the character. As you already see, a character is a type of pawn that includes ability to walk around. This is pretty self-explanatory. I'm simply going to click on next, and over here we are going to give it a name. And I'm going to call this bad boy Battery Man. So here I'm going to say Battery Man. I'm going to click on create, and of course we do need to wait for C++ and Unreal Engine to compile, to have mercy upon our poor souls, because it does take a lot in comparison to Unity in terms of waiting and so on and so forth, yada, yada, yada. So there you go. This is my project. Let me just quickly go over here to tools and options. And here I'm going to find the fonts and colors. Let me just check the font. So it's 14. Did I click here? Is it okay? Yeah, it's actually 14, but it's too big for a 14 font. I think I need to resize this later on. Anyways, it's not important. You don't care about that. What do you care about is that over here, when you create a new class in C++, we have two files. We have batteryman.cpp and we have .h. What the hell is this? Well, in the .h file over here, you are going to implement, or actually you are going to define the variables that you are going to use, such as, for example, float, health, integer power, create functions, and then over here in the CPP file, we are going to implement that. So let's go in the battery man, and before I proceed, over here, as you already see, we can include frameworks and classes that we want to use. So this is the first thing that I'm going to do, and make sure that when you include new classes, that you include them above the dot generated H file of your default class. What does that mean? Well, over here I created a batteryman class, and automatically we will have a batteryman dot generated H file. If I created a Carl class, then we would have Carl dot generated H file. So make sure that above this file you include over here that you include anything else that you need. So here I'm going to say include, and for example, we need one of the things that we need is a camera, and over here I'm going to say camera component. If I were to use this and I include it below, it will not even allow me to compile. So over here I'm going to include below, Control-Shift-B to compile it, or you can go here under build and click on build solution and wait for it to compile. You will see automatically it has failed. And even here it will tell you on line 11 in the batteryman.h file you have an error, include found after dot generated H file. So it's not allowing you to include anything after the dot generated H file. Make sure that you memorize that, or otherwise you will have issues, and there you go. So I'm going to include everything that I need before I proceed to do anything else. Except for the camera, I also need components, so components and slash over here. I also need the capsule component, and here make sure that you end the quote, so include next, so it's include and in quotes. I also need components and slash, and this one is going to be the static mesh component. Also hashtag include, and in quotes we are also going to need components slash, and this one is going to be input component. We also need slash, or actually hashtag include, and over here game framework, so game framework, and inside of the game framework I need the character movement component. There you go. We also need an include. I know it's tedious to do this, but we need to do it. So it's game framework, and here we need the controller dot h and include game framework. So game framework, come on, here it is. And I need the spring. So it's spring arm component, and we also need one more, which is include. So include blueprint, actually blueprint, not blueprint, and slash user widget, because later on we're going to use a widget to represent the power of our player, yada yada yada. So the first thing that I'm going to do is I'm going to declare the variables that we need right now. So I'm going to do that right here below the public. You see over here public, we have batteryman, and this is the constructor. If you don't know what a constructor is, please watch my C++ tutorial series, which you can find here on YouTube. Simply type Awesome Dude C++ tutorials and you will see that. So a constructor will allow us to create an object out of this class. So this is the constructor, and right here below the constructor we are going to have a U property, and it is going to be visible anywhere. And visible anywhere basically means that we will be able to see it over here. If I, for example, select, I don't know, let's say this cube over here, and it's not important what I selected, but it's important over here in the details panel. This is the details panel right here. So over here in the details panel we will be able to see the variables that we mark with visible anywhere. Now I'm also going to say here blueprint, so blueprint read only, so which means it is going to allow me to only read these variables in the blueprint and not edit them. And the category is going to be equal to camera. So category is going to be equal to camera, and this is going to be a U spring arm component, which is a pointer. I'm going to call this one camera boom. Basically what this is I am going to use this to attach a camera to it, and this is going to hold the camera. Now I'm also going to copy this over here and paste it, because we are going to also have another U property, visible anywhere, blueprint read only, category camera, and it's going to be U camera component, also a pointer, which is denoted by this asterisk or star, however I want to call it, and I'm going to call it follow camera. If you don't know what a pointer is, make sure that you watch my C++ tutorial series. So make sure that you watch my C++ tutorial series. There you go. So we have the camera component. What we need to do now is go in the .cpp file and implement this bad boys. Now, what I'm going to do here inside of the battery man, which is basically going to be our constructor, as you can see, and here we are going to initialize some variables. We can also do that in the begin play, but the first initialization will happen over here. So what I'm going to do is I'm going to get the reference to the capsule component. And what do I mean by that? Well, if I go now over here inside of the content, and this is what we are going to do. So right click and create a folder called blueprints. And this is where we are going to store our blueprints. I'm going to right click and I'm going to create a blueprint class. And now I'm not going to select any one of these classes over here. Instead, what I'm going to do is I am going to click on here, all classes. And here I'm going to filter for the battery man class. And here it is. You see battery man. Here it is. You see battery man class. This is what we want. So click on it and simply double click it and select it. And there you go. And this is going to be battery man underscore BP. And since he has inherited from our battery man class, automatically he will have a capsule component, a mesh, and a character movement. Basically, this is inherited from the character. So you see, we have the capsule component, which is over here. Over here, we have the capsule, half, height, and radius, and all of the good stuff. We have the character movement. Here is our mesh that we are going to use. So here, for the skeletal mesh, I'm going to select the mannequin, which is this bad boy over here. For his animations, we are going to select third person anim BP, as you already see. And let me just compile that. So you see already now I am going to, well, change the position of this bad, but I'm also going to rotate him. Let's go rotate him over here to 270 degrees. And we are also, as I said, going to reposition him. So moving him a little bit down, but we will first wait to resize this capsule. And we're going to do that right now from our code. So let's go back here in the code. And here, the first thing that I'm going to do is I'm going to say get the capsule component, which we just saw, and it is a pointer. So we need to say like this minus sign, greater than sign, and then init capsule size. So here I'm going to say 42.0f and 96.0f. This is for the half width and the radius of the capsule. This is going to change it over here. We can also change it here, but we're learning C++, so this is why we're doing it over here. Now, when we rotate, I want to forbid the character to rotate. Instead, I'm going to allow the camera to rotate. So over here, I'm going to say use controller. So use controller pitch rotation, or rotation pitch is equal to false. use controller yaw rotation. So here I'm going to say yaw. Here it is. I'm also going to say false. And now we also have roll. So use controller roll rotation. Here it is. We're going to set that to be equal to false. Now this is not going to allow the character itself to rotate. Instead, we are going to affect the camera. So we're going to allow the camera to rotate. Now we are going to get the character movement. So over here I'm going to say get character movement, and it's also a pointer. So we need to say here orient rotation to movement, it's equal to true. What the hell is this? Is that will allow the character movement to rotate in the direction where it is moving. So orient rotation to movement. I'm also going to say here get character, so character movement, and over here for the character movement, we are going to say the rotation rate now. So we are going to rotate towards our movement, but the rotation rate is going to be equal to F rotator. So F rotator, 0 for the X, for the Y it's going to be 540, so 0.0 F, and also for the Z it's going to be 0. So this is the rotation rate, so the rate by which we are going to rotate. I'm also going to set here get character movement, but let me just copy this because it's tedious to type every single time. I'm going to say jump Z velocity is equal to 600. So when we jump, our velocity is going to be 600. And lastly, I also have the air control. So here I'm going to say get character movement, air control, which is how much can we control our character in the air. I'm going to say 0.2, which is going to allow us to, well, slightly control our character in the air. I'm still not going to compile this. I mean, I can, but we cannot test it out because I simply set these values. But now I'm going to create the spring arm and the camera boom. So let's go over here. I'm going to say camera boom, and that's going to be equal to create default sub object, which is going to be a type of spring arm component. And the name of it is going to be text, and inside of the text we are going to add the name. So the name that we are going to see here is camera boom, and this name is simply how are we going to name it, this component over here inside of the components that we see. So basically, you see we have the character movement. When we see our spring arm component, the name is going to be camera boom. There we go. So now I'm going to say camera boom is going to be equal to, or actually over here, we're going to say set up attachment, and we are going to attach it to the root component. And the root component is this basically. So this is the capsule, which is the root component. So we're going to attach it. So it's going to be a child of the capsule. And moving forward, what did I do? So moving forward, I'm going to say the camera boom. And over here, we are going to set the target arm length is going to be equal to 300. This is basically how far away is this spring arm going to be away from the user. So it's going to be somewhere around here, somewhere around there, which is how far the camera is also going to be away from the player. I'm also going to say here camera boom, and here I'm going to say use pawn control rotation. That is going to be equal to true. This is going to rotate the arm based on the controller. So it's going to rotate the arm based on the controller. And in order for us to test this, I also need to create the camera. So here I need to say follow camera is going to be equal to create default sub object of camera component, and the name of the camera component we are going to add in the text. So over here in quotes, because it's a string, I'm going to say follow camera, and we're going to attach now the camera to the camera boom. So we are going to say follow camera, since it's a pointer. We are going to say here set up attachment, and I'm going to attach it to the camera boom like this. And we are going to say use spring arm component, colon, and here I'm going to say socket name. This is going to attach the camera at the end of the boom and let the boom adjust the match controller rotation of the camera. And lastly, I'm going to say follow camera. So it's follow camera. Come on, man, follow camera. Thank you. It's not giving me autocomplete. use pawn controller rotation, or control rotation, is going to be equal to false, which basically means the camera does not rotate relative to the arm. Now, pay attention over here. We don't have anything. As you can see, we have the capsule, arrow, and I said we don't have anything, but we have capsule, arrow, but no. We have the capsule component, arrow component, mesh component, character movement. When I compile this, so Control-Shift-B to compile, you can also go here on the build and build solution. I'm assuming on Mac, it's Command-Shift and B. So there you go. And let me just see over here. Unknown variable specifier visible anywhere. So it's on Batteryman age 32 and 35. I think I misspelled this. So let's go over here. Visibile. Yes, I did. It's visible anywhere. So you see, I've misspelled that. So let's try and compile it again and see if now I can spell it correctly. So let's go over here. Let's wait for the compile to finish. Come on, come on, come on. There you go. So compile has succeeded. Yay! Thank you. So let's go back over here now. Notice we have the camera boom. We have the camera follow. This is the camera boom. You see this? This is that target length. You see? Let me just go over here and in the CPP, you see this is that target arm length. This is how far away it will be from the camera. And since we attach the camera away from the player, that is, since we attach the player, as you already see, it is pointing on the player. There you go. There you go. Now, we cannot spawn this player in our game. Even if I do this, if I go in the blueprints and put the character over here, here he is. And if I run this, we see another character. This is our own default character. You see, this is our default character. So this is not what we want. And in order to change this, we need to do one thing. We need to go back here in classes, and I need to right click and create a new C++ class. And this one is going to be, and click here on show all classes. So you see over here, click on show all classes, and in the search, filter for game mode. And select the game mode and click on next. And over here for the game mode, I'm going to call this one batteryman_game mode and click on create. Of course, wait for everything to compile and save and so on and so forth. But why do we need the game mode? Well, because the game mode is the one who is going to determine who is our default character that we are going to spawn. As you can see, we have it over here. Don't worry about it for the moment. Let's go back in the blueprints and right click over here and create a blueprint class. And here for all classes, I'm going to filter for batteryman game mode. Here it is, so batteryman game mode, and click on select. And this is going to be our, as you see, batteryman_game mode_BP. There you go. Why is this important? Well, now we need to go in the project settings, and over here for maps and modes, it's right here. And here for the default game mode, we are going to select over here the batteryman game mode BP, not the batteryman game mode, but _BP. And now here I can click on this drop down list, and here for the default pawn class, instead of the default pawn, I can select my batteryman BP, so batteryman blueprint. And if I go back, and even if I delete this batteryman BP now, and if I run the game, we see this is our batteryman. So this is the batteryman that we want, the bad boy, the new kid down the street, whatever you want to call it. So this is our batteryman. Now, we cannot move him, we cannot do anything. The reason for that is because we did not program that. So let's get into it. Let's go back over here inside of our batteryman H, and right here below where I have declared our camera, follow camera that is, I am going to declare void move forward, which takes a float axis as a parameter, and void move right, which also takes a float axis as a parameter. And we also need a boolean BDead to determine if our character is dead or if he is not dead. Now this is essential to know because we're going to use BDead to determine if we can move or not. So let's go back over here, and in the CPP right below our follow camera, we are going to say BDead is equal to false to set the default value for our BDead. And we do need to implement our move forward and move right. A simple way is right click on it, quick actions and refactoring, and over here create definition move forward in batteryman CPP, and it will automatically create it. And there you go, here it is, move forward. Another way that you can do it is you can say void a batteryman colon, you can say here move right, and here we can say float axes like this, and now we have also implemented here move right. So a much simpler way is right click and do your thing. Now what I'm going to do is I'm going to take these two functions and I'm going to copy them and remove them from here. I'm going to place them right here below our input for binding. And over here is where we are going to bind all that. So this is where I'm going to bind the input that we set up in our game. And now you're wondering, but teacher, when did we set that up? Well, good question, handsome stranger, because we created this third-person project right here under project settings, and here for input, which is right over here. Here is the input. We have the default input over here. So we have the mappings and we have the axis mappings, action and axis. So we have the move forward, move right. We have the look up rate and look up. This is what we are going to use, or actually, excuse me, the turn rate and the look up. So this is, we are going to use to move the mouse up and down. This is what we're going to use to move the mouse left and right and to look around. And this is what we're going to use for our movement. And the jump we are going to use, well, for the jump. There you go. So how can we do that? Well, we need to go back over here, and this is the input. This is where we are going to bind that. So we need to take the player input component, and first I'm going to bind the mouse. So over here I'm going to say dash greater than sign, and I'm going to say bind axis, and I'm going to bind the axis name called turn, and I'm going to bind it inside of this, and I'm going to bind it with a pawn, colon, add controller Yaw Input. So Yaw Input. What the hell is this, teacher? What are you doing? I'm gonna start. Don't start crying, man. And it's not asterisk, it's actually and sign. So this over here is going to bind this turn, which is this over here. This is it. So here is the turn, you see? This is the turn, you see? So this is the name of the input that we are binding, and we are binding it in this. This means referring to this class over here. So it is binding it inside of this class. And here we are saying that we are binding it to our pawn's controller Yaw Input. Now that is, if I go over here and battery man and select them, you see pawn, basically it is going to allow us, you see over here, it is going to allow us. And actually over here, this also needs to be unchecked, so save that. But even if we run our game, it will be unchecked. But it is going to allow us to control the yaw from the player. Why the yaw? Because that is the rotation of the player. So if I go over here, select the mesh, and you see here, the Z is the yaw. So if I rotate him, you see he is rotating left and right. So this is essentially what we are doing. So let's do that for the Y rotation as well. So I'm going to simply copy all of this over here and paste it. And now I'm going to, instead of turn, I'm going to use look up. So this is the name of the axis, which is right over here. Here it is, look up. And you see we're binding it. Basically, we are going to activate it when we move our mouse Y. So let's go back over here inside of this. And here, instead of add controller yaw, it is going to be the pitch input. So over here, we are going to say pitch input. Control Shift B to compile this and save so that I can show you this right away, because we can test it out right now. So we can test it out right now. And let's go quickly back. So here, and if I run the game, you see now, I can start moving. You see, I can start moving my character, as you already see. Actually, I can start watching, or watching where he is. I mean, left and right and up and down and rotate, because I bind that to the pitch and the yaw. So moving forward, I'm also going to use our player input component, and I'm going to bind an action now, and the name of the action is going to be jump, and I'm going to bind it inside of this. But I'm also going to bind the press and the release of it. So here I'm going to say IE pressed, comma, inside of this, and I am going to use over here and sign. I'm going to say a character jump. Now this a character jump is a function inside of the character class that we can use to jump. And over here I'm going to copy this and paste it. And here I'm going to say released. So released. There you go. And here we are going to say stop jumping for the character. And we can test this out as well. Now these are built-in functions inside of the pawn. So this one is in the pawn and this one is in the character, that come because we have inherited the character inside of our batteryman.h, which means that we have also inherited all of its functions. So if I go back over here and hit the play button, we will see now that I can also jump. You see, we can also jump. And by the way, if you see our character is above the ground, now the reason for that is because we need to place him a little bit lower. So let's go over here, take the mesh. I'm going to click here to snap the size to 1 and move him down a little bit more. Something like this can do, I believe. Maybe a little bit more over here. I think this is okay. Compile and save. And if I go back now, our character is standing on the ground, as you see. Well, a little bit above the ground. But yeah, you get the point. So just move him down. Now we can jump, we can move and look around, but we cannot, actually we cannot move. We can look around, but we cannot move. So now it's time to bind our move forward and move right. So over here, I'm going to say player input component. So player input component dash and then greater than sign. I'm going to bind the axis, and the name of the axis is move forward. And I'm going to bind it inside of this, but now I'm going to bind it with my batteryman move forward. So copy this, a batteryman move forward, copy this, use the and sign and simply paste it. So this is going to bind the move forward action, which is this actually axis, this right here. This is the move forward and this is the move right. It's going to bind it inside of our, and basically over here when we press the W or the S key, it will be executed. For the move right, A and D key. And when we do that, it will call this function over here. Let's do that for the move right as well. So copy and paste, and here it's going to be move right. By the way, very, very, very important. If the names don't match up, so if this name over here doesn't match up with the name over here, you see, move forward, this name over here needs to exactly match up with the name over here with capitalization and everything, or otherwise it will not work. And let's go over here and paste the move right. And there you go. So now let us code these to actually move our character. So over here, what we are going to do in move forward, we are going to test if we are not dead. You see, I used an exclamation mark, which makes what's after it the opposite. And here it's lowercase d, or actually e. Essentially, if we are not dead, and when we die, I'm going to set that is equal to true. But here, the exclamation mark will make what's after it the opposite. If it's false, then this will make it true. So if we are not dead, I am going to move the character. So here I'm going to create a constant, which is going to be f_rotator, which is basically the rotation. So rotation of the character, which is going to be equal to controller. And here I'm going to get the controller rotation and constant f_rotator, which is, and here I'm going to find out, I'm getting these rotations to find out the forward direction. So here I'm going to say yaw rotation is going to be equal to, well, actually f_rotator, yaw rotation like this, and I'm going to say 0 for the x, and here I'm going to say rotation. So it's actually this rotation over here. So rotation dot yaw, and 0 for the z-axis. And now we are going to calculate the forward by using constant f vector, and I'm going to call this one direction, which is the forward direction. I'm going to say f rotation, so f rotation matrix, and we're going to pass the yaw rotation inside, and we're going to say get unit axis, actually axes, so only one axis, and we're going to get the e-axis, so a-axis, colon, x, which is the forward. This is going to calculate the forward direction of this vector. So of the yaw rotation vector, it is going to calculate the forward direction, and here we're going to say add movement input, passing here the direction, and passing the axis over here. And what is this axis? Well, it's basically this over here. So this is the axis. Now what I'm going to do is simply copy all of this and paste it back over here. And here for the calculating of the direction, because over here we need to calculate the right direction because we're moving right. Here instead of x, I am simply going to use the y-axis. And there you go. So I'm going to use the y-axis. And that's all there is to it. So I'm going to Control-Shift-B to compile this bad boy. So simply compile it and wait for the compilation to finish. So wait for the whatever you're going to call it. I don't know. I know that you will judge me in the comments below, but I do not care. I am here to entertain you. So there you go. Build has succeeded. I didn't make an oopsie. So now if I go back over here and if I try to move, we will see that we are moving, you see, because I'm pressing W and it's moving. And if I press the A key, you see he's now gonna start moving to the left side and rotate to the left side. Move over here to the right and rotate. This is because of this right here. This is because of this right here. Orient rotation to movement is gonna orient or actually start rotating the character towards so it's gonna start rotating the character towards the direction where he is going. So there you go. There you go. Okay, now we have the character and we can move. Let us create our pickup. So inside of the blueprints, I am going to right click and let me just, okay, right click over here, blueprint class, and it's going to be a pawn. And I'm going to call this one pickable. So pickable item underscore BP. And let me just double click it. And over here, we are going to add a static mesh. So click on the default scene and here add a mesh component. So there you go. Actually, static mesh. Here you go. So we are going to add a static mesh. And for the static mesh over here, click on it. And for the mesh, the actual mesh, I am going to filter for SM. And let me just find it. Here it is. This is what we want. So this is going to be our pickable item. Now, at the moment it's too large, so what I'm going to do is scale it down. But notice over here we have the 3 scales. When you click on this little, how's it called, this icon? I forgot. This lock icon, lock, thank you. So click on the lock icon. So when you change only one axis, it will change all 3. So X, Y, and Z, set them to 0.2. This is for the scale, as you can see. Compile and save. And I'm also going to click on the default scene and attach a box collision. There you go. And this is our box collision. What I'm also going to do for the box collision is I'm going to move it here on 4, so set it a little bit above. And actually, should I move this one down? Yes, I should. So this one is gonna go -20 down. I think this is it, so that we can place it inside of our box. And of course, I'm going to resize the box. So go over here for the box extent for the 32, it's going to be X.15.7, and for the Y it's going to be 23.8, and for the Z it's going to be 23.2. So this is basically it. So you see, this is it for our, there you go. Everything is cool. Now if I go back over here, and if I place it, we will be able to see it. So here it is. And actually, I'm going to put it like this, a little bit, resize it just a little bit. And what I'm going to do is go back in the static mesh for it. And over here for the physics, I'm going to click on simulate physics because it is going to add physics to it, which means now it's going to fall down. You see, it fell down. And if I touch it, you see what's happening. We can roll over it, but this is not something that we want. Instead, what we want is we want to detect collision when I, well, go over it. So in order to do that, we need to go back over here in the blueprint, and for the batteryman H, right here below the dead, we're going to declare a couple of more variables. The first variable is going to be U property, and this one is going to be visible anywhere, so anywhere, and it's going to be blueprint read only. Now I need to do this blueprint read only because this variable is going to be our float power. We are going to access it inside of a blueprint. If I don't add this blueprint read only, we will not be able to access it, and we will see that when it comes. And here also I'm going to have U property, and this one is going to be edit anywhere. Now the difference between visible anywhere and edit anywhere, so here I'm going to say float, and this is going to be our power underscore threshold. Now the difference between them, visible anywhere and edit anywhere, is if I compile this, we will see in a moment that visible anywhere we can see it but we cannot edit, but the edit anywhere we can see it and edit that variable, then edit that variable. So if I go back, build succeeded, if I go here inside of batteryman, if I select them over here, there we go. So you have the power threshold and we have the power. You see, power is not editable, but the power threshold is, and I can go over here and I can set 3 for the power threshold, for example, compile and save, but I cannot do that for the power itself. So what I need to do over here below is I need to declare a U function. So U function like this. This is going to tell the delegate system that the next function is going to be tied to a delegate. So over here I'm going to say void on begin overlap. This is the name of the delegate, or actually my function. And here I'm going to say class. These are now the parameters that I'm going to put inside of this begin overlap. So we're going to have a U primitive component, so component, which is going to be a pointer, and I'm going to call it hit component, so component that we hit. We are also going to have a class here, a actor, so actor, which is a pointer as well, and I'm going to call it other, so other actor. This is the other actor we have collided with. We're also going to have class U primitive component asterisk, and this is going to be the other component, so the other component we have collided with. We're also going to have int32 other body index, so other body index. We're also going to have bool b and from sweep, and we're also going to have a constant f hit result which is going to be from a pointer, and here we're going to say sweep result, and there you go. So this is, now ignore all these parameters, we are only going to use the other component, but we need to declare it like this because, well, this is the declaration of it. Now if I try to command or control shift B to compile this, it is not going to work. So it's not going to work, and the reason for that is because we did not implement, this function that we have just created. So onBegin overlap, you see, it is complaining it doesn't have the implementation for onBegin overlap. So I'm going to right click and create a definition of it in the CPP. So let's go over here, and this is my onBegin overlap. So I'm going to copy it, and I'm going to go over here below my inputs, move right and whatnot, and this is where I'm going to declare it. And I'm going to hit enter to see all the parameters. There you go. And this is where the magic is going to happen. Now what we are going to do over here is that we are going to test if we have collided. Now inside over here, if other actor, you see, if the other actor that we have collided with, and if that actor has a tag, so actor has tag, and here I am going to say recharge tag. There you go, this is the name of the tag. What I'm going to do here, first of all, I am going to use the UE log like this to print to the console. So here I'm going to say log temp, so log temp, here it is, warning, and I'm going to say for the text, and here I'm going to say collided with, we have collided. Now what we need to do, because we're testing if the other actor has a tag recharge, we do need to go over here and select the pickable item and click on the pickable item and go over here for the actor of it. So you see here we have the actor, click here, show advanced, so click there. And when you scroll down, we have here tags, and it's an array. We can click on the plus sign over here. So click on it, and here paste the recharge tag. Compile and save in order to make this work. And I also need to compile this over here to make this work. So now when we collide with that other actor, we should see in our log that we are printing, well, log, or we have collided with the actor. So collided with. Let's go over here, and we should see that in the output log. Now, what do you think? Are we going to see it? Now, since I've asked it, you're going to assume that we're not going to see it. And it's true. We don't see it, you see? Now, the reason for that is over here, we do need to click on the box, and we do need to specify the collision presets. But also, before we do that, we need to do one more important thing, and that is we need to go over here inside of our Batteryman CPP. And by the way, I'm also going to, no, I'm not going to destroy the other actor. We'll do that later on. But over here in onBegin play, over here, begin play, we do need to bind the onBegin overlap with the component. So over here, what I need to do is I need to say get capsule component. So get capsule component, and we need to say over here on component begin overlap dot add dynamic. Now don't worry if you don't see add dynamic, simply type add dynamic, and we are going to add this and here and the sign, and we need to copy this over here, a Batteryman onBegin overlap. So let's go over here and paste it. So this is what we need to do. So Control Shift B, because if we don't do that, we didn't bind the capsule component from our own capsule component. We did not bind that with the onBegin overlap that we have created, which means it will not trigger it when we collide with a game object, or actually with an actor. So if I go now over here and if I hit the play button, so if I collide, you see, collided with. So now we do see, let me just go over here and clear the log. And now we see that it has collided with. We are printing it. You see, we are printing it, but for some reason it's only printing it once. What also, if for some reason you don't see it, what we also need to do is go over here in the pickable item, and for the box, also over here, you can set the collision presets. You see over here, we're overlapping all dynamic, which is okay, but we can also set a custom collision, and for example, we can ignore everything except for the world dynamic, and the physics body. So compile and save. This will tell us that we are going to collide with dynamic game objects and physics bodies. What is a dynamic game object? Well, it's a game object that here it's set to movable. It's a dynamic, it moves. So it's a dynamic one and it is moving. Let's go back over here and clear the log and try again. Actually, let me clear the log. Here it is. And if I touch it, so let's try it over here. Now we are not colliding. You see, now we are not colliding. Now the reason for that is we need to do the same thing for our capsule component. So going back over here, and let me just see, here it is the collision presets, and we set it to pawn, but we want to custom collision, and we want to block all except the world dynamic and the physics body. So make sure world dynamic and physics body. All else we can block. So all else we can block because our pickable item is a physics body. And it's, you see over here, it is physics. Actually, the static mesh is set to be physics body. So it will work as well. Let's go back over here and let me just clear. Actually, why am I clearing? Because every time I run the game, it is going to unclear it. So now you see we have collided and it's printing multiple times. You see? It is now printing more than once, but before that it was printing only once. So there you go. We have collided with. Now, what I'm going to do, what's actually going to happen when I collide with this pickable item? Well, when we collide, we are going to go back over here, and instead of printing this, I'm going to remove it. And what I'm going to do is I'm going to use the power, and I'm going to say plus equals to 10f, 10.0f, 0.0f, to add to the power 10. And I'm going to test if our power is greater than 100f. We are going to say power is equal to 100f, so not allowing the power to go above 100. And we are also going to destroy the other actor. So over here, other actor, destroy to remove the other actor from our game. And that's basically all there is to it. Now I'm also going to go here on top before I compile this, because the initial value of our, so over here, power, the initial value of the power is going to be 100.0f. So Control Shift B, and I set N, so it's actually Control Shift B. To compile this, we will only see that our, what's the name of it? The actor, the pawn, the collectible item is going to disappear, because we do need to implement a UI widget to display that to the user. So if I go back over here and if I hit the play button, now when I pick it up, bam, you see, we see it. It's not there anymore. So it's not there anymore. What I need to do now is go over here in the blueprints, and I need to right click over here, and we're not going to go in blueprint, but user widget, and create a widget blueprint. And this is going to be our blueprint to display the player power. So over here, I'm going to say player power underscore UI. There we go. And double click it. And it's going to be a simple slider. Actually, let me just see progress bar. Here it is. And I'm going to resize this progress bar. I'm going to put it over here. Now also make sure that you click here on anchors and set the anchor. So set the anchor at the bottom center. So this is going to be our player power. And I'm also here for the percentage. You see, I'm going to go over here and I'm going to say it's going to go from right to left. So if I try to move it, it's going to go from right to left. There you go. Compile and save that. Now, before I bind this to the player input and so on and so forth, let us spawn this bad boy inside of our, well, inside of the game. And in order to spawn it in the game, we do need to go back here in our player H, first of all, battery man. And right here below on begin overlap, I'm going to declare a U property, which is edit anywhere, comma, and category. So category is going to be equal to UI HUD, or HUD elements, however you want to call it. And T subclass of, this I'm going to declare it, user widget, like this. And here I'm going to say player power widget, so widget class, like this. And below we are going to say user widget, which is going to be a pointer, and there's going to be player underscore power widget. So widget, come on. There we go. Now, if I try to compile this, let's go Command or Control Shift B to compile it. It is going to throw an error. So let's try it out. Let's see if it's gonna work. And yada yada yada, bam, failed. You see, it has failed. The compile has failed. Now, the reason for that is we need to do this. We need to go over here. So make sure that you go under Games. So here under Games, and then under Battery Collector, and then under Source, and then under Battery Collector again, and search for the file that has .buildcs. Here it is. .buildcs for the last name. So .buildcs, double click it. And over here, as you see, where we are adding all of these strings, so public dependency modules name, add range, here at the end, you need to say, comma, in quotes, so in quotes, open quotes, and you need to type UMG. And now Control Shift B, and now it will compile, because otherwise it will not compile. So it's simple like that. So otherwise it will not compile. Let's try it out and see if it compiles. Now, bam, you see build has succeeded. So you need to add UMG over here also in order to use UI widgets. Now let's go over here and show you something. So here we have the battery man. I set it to be edit anywhere for the player power widget class. And if I go back over here in the battery man and select it, notice over here on top, here it is, I can select that widget class. So I can click on the drop down list and I can select player power UI and compile and save that. Which means I can go now, I have attached it over here, which means we have a reference to it, and I can go back here in the CPP, and right here after we attach the onBegin overlap, I am going to test here if our player power widget class is not equal to null pointer, so null PTR. We are testing this to see if it's not equal to the null pointer. Now the reason for that is we might not have attached it over here. So this test is going to fix that. So if it's not equal to null pointer, I'm going to say player power widget is gonna be equal to, so actually player power widget, so player power widget is gonna be equal to create a widget from this class, so from this class, but first of all we need to get the world because the world is the one who is going to create the widget from the class over here. So create us a widget from this class that we have attached, and I'll call player power widget, so only this over here, player power widget, and add to viewport. So add the player power to viewport. Control Shift B to compile this bad boy. And let's go and test it out and see if it actually works. So if I close it, but first of all, I need to make sure that I did not do any oopsies. Yada yada yada, and here it is. The build has succeeded. Let's go now, and if I hit the play button, we should see our power inside of the game, which indeed we do. So we do see it. But now, let's start subtracting that power. So that happens over here. Select the power, and here for the percentage, we need to click on this bind and create the binding. And here, I'm simply going to say get power like this. Compile and save. And here I'm going to break this node, and what I'm going to do is I'm going to say over here, cast to battery, so battery man blueprint, and I'm going to cast the get player pawn. So the player pawn is the one that I'm casting over here. And notice now what I'm going to do. I'm going to get the power. You see, get the power. This is only available to us because over here inside of the battery man H, when I have declared the power, I set blueprint read only. If you don't type this out, you will not be able to get the power same as I did. So you will not be able to get that power. Now you can try it out. I'm not going to try it. You can remove this from here and compile and save that and try to see that on your own. I'm not going to do it because it will take time and I know it's not going to work. So let's go over here and I'm going to get the power and I'm going to divide the power. So first here I'm going to say divide by float and we're going to divide that by 100 and then we're going to plug this into the return value. Why am I dividing the power by 100? Because if I go back here in the designer, the percentage goes from 0.0 to 1.0. which means it only has 2 decimal point numbers. So this number power needs to be that number. We set the initial value of the power in the CPP to be 100. So if I divide that by 100, it's equal to 1. If I have here, for example, 98 divided by 100, that's 0.98, which will set the value over here inside of our power. And in order to do that, we're going to do in the tick. And the tick is called every frame. So over here inside of the tick function, we are simply going to say power. So power minus equals the delta time. So delta time multiplied with the power threshold. There you go. Now we do need to compile and save this in order to work. So make sure, compile and save this bad boy. And let's try it out. Let us try it out. So come on, yada, 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 yada. I'm singing to you, by the way. And if you're watching this, check out the Academy. You will see more Unreal Engine courses. Link is in the description below. I'm probably running a discount because I want to enable you guys to enroll in the Academy as cheap as possible. So if I go back now, hit the play button, you will see, pay attention how it is moving down. So it's removing the value. And if I pick up the collectible item, it is going to add 10 to it. So if I pick it up, come on, pick it up, I added 10 to it. So let's kill the player when the value gets to 0. So that's gonna happen over here, right over here. We're going to test if our power is less than or equal to 0, like this. And prior to that, or actually after that, we're going to test if we are not dead. So if be dead, so if we are not dead, automatically here we're going to say be dead is equal to true. So it is equal to true. And now I want to make sure that my character falls down like a rag doll. Now, in order to do that, we do need to say get mesh. So get mesh like this, and simply set simulate. And in order to actually get the mesh and for this to work, I mean, this will work without it, but it's not giving us auto completion. What we need to do is go here on top, and right here I need to say include, and I'm going to include components / skeletal mesh component. And while I'm at it, I'm also going to include a few more frameworks that I'm going to use, such as game framework. And here I'm going to say actor H, and the last one is going to be hashtag include, and here I'm going to say Kismet, and we're going to include gameplay statics. There you go. This is for restarting the game, this gameplay statics. Now that we have imported the skeletal mesh, I'm going to say here get mesh like this, and I'm going to say set simulate physics to be equal to true, and this is going to simulate the physics. And over here I am going to restart the game, and let's do that right now. In order to do it, we do need to go back. Let me just find it here right below our edit anywhere. We're going to say void restart, so restart and implement it. So right click, not rename. Come on, man, not rename. Why are you doing this to me? Why? Cancel. Restart and create declaration definition. So this is what we want. Come on, man. What is this? Why? Finally, thank God. Let's go here and find the restart. Where it is. Where did it declare the restart? Here it is. So I'm going to take the restart. Come on, thank God. And let's go back here, right above our onBegin overlap. So what's gonna happen here in the restart is I'm going to call our gameplay statics. I'm going to say U gameplay statics like this, colon, open level like this over here, and we're going to load the current level. So I'm going to say here this F name of the level. So this is the name of the level, asterisk because we get a pointer, get world like this, and we are going to say get name. There you go. And over here I need to say false like this. So this is going to open a level inside of this, which means from this class, referring to this class, and get the world and get the name. So getting the name of the world, asterisk over here because we're dealing with a pointer, and false. And there you go. So if I go back over here, after we simulate the physics, I am going to call this function by using ftimer handle, and I'm going to call this one unused handle like this, because here I'm going to say get world timer manager like this, and I'm going to say dot set timer, and we're saying here dot because this is not a pointer, this is a reference. So set timer, and over here inside I'm going to say unused handle. So here we need to say unused handle colon this, and over here I need to say and a battery man colon restart game. So this is the function that I want to call after 3 seconds. Do I want it to repeat? No, I do not want to repeat. Did I type restart game? What did I type? How did I restart? I simply type restart. Okay, so let's go over here and it's restart. So it's only restart. So this get world timer manager is going to set the timer by using this unused handle. This is a parameter we need to pass. Inside of this, which is this class, this is the function we want to execute after 3 seconds. So here we specify the time, and false meaning we don't want to repeatedly call this function after 3 seconds. What I'm going to do is Control-Shift-B. Don't worry if you see this red line over here, it's still going to work. Incomplete type not allowed. This is because of the connection of Unreal Engine and the connection of our Microsoft Visual Studio. You will see now the build has succeeded. So you see, even though it's reporting here an error, the build has succeeded, so it is going to work. So if I were to test this out, and if I hit the play button, bam, ooh, what is glitching, people? Look at the glitch, man, look at the glitch. Now, the issue here is, I believe I know what's the issue, the restart. We do need to rename this to restart game because I do believe the restart is built in, and for some reason it's calling it over and over again when we, well, try to override it. So I do believe we need to say restart, and let's go and try it out right now. So let's see, I'm going to build this bad boy to see if I did an oopsie while building this or not, So come on, let's go over here. Build has succeeded, great. Now quickly over here for the player. So let's go in the blueprints and battery man, there we go. For the player over here, make sure that you select him, and over here set the power threshold to 30. So that this drops very quickly and we can see the ragdoll effect, but we are not going to see the ragdoll effect, as you can see over here. So pay attention to the player. So we don't see the ragdoll effect, you see? No ragdoll, he's not even falling down. For you, maybe he's falling, but that depends on here. Let me just go over here and see this is set to the pawn, this is okay. And for the mesh over here, it's set to the pawn, or actually, let me set on the character. So is it a character mesh? I believe it is. So compile and save. Let's go and try it out right now to see if he will fall down. And still he's not falling down. We are restarting our game though. So you see the game is restarting. So depending on the settings over here, and like owner, block, or pawn, spectator, physics, asset. If I set here to ragdoll, compile and save, and let's make sure now it works. So let's try it out right now. Yeah, for some reason he is not falling down. Maybe with you he's falling down, but for me it's not falling down, which is okay. So if I go, let me just find out Batterman CPP. If everything is okay, let me just, over here, set simulate physics, everything is okay. Oh, okay, but let's fix this. Let's add a ragdoll. So here in the content, I'm going to right click and new folder, and I'm going to call this one physics. And inside, I'm going to right click and go under physics. So let me just find where it is. Here it is, physics and physics asset. Click on that. Click on the skeletal mesh over here. And I'm going to call it my ragdoll. There we go. And this, everything here is okay. Click on create asset. There we go. If I click on the ragdoll and if I simulate, you see this is the ragdoll effect that I want. And if I go in the battery man, because we have selected its mesh, you will see over here in the physics, here it is, physics. You will click on the drop-down list over here. It is currently using, so click on the drop-down list. There you go. It is currently using my ragdoll. So if I try to test it out, so let's go over here and try to test it out. Bam, there you go. You see, there you go. The ragdoll is falling. Now, the reason why the ragdoll is falling is because over here on the mesh, for the collision, I set it on the ragdoll. If by any chance it's set on the pawn, I believe it will not work. So if I try it out right now, let's see if it works if it's set on the pawn. Bam, you see? You see what you have? So if for any reason you see this, you see? If he's catapulting for whatever reason, then simply go click on the mesh and scroll here for the collision. You can set the collision to the ragdoll. There you go. Collision presets, ragdoll, compile and save. But let's just make sure that I can pick up this collectible item, which is cool. I can. And my ragdoll, you see now, bam, he falls and we can restart our game. There you go. Let's go into Battery Man over here and change this from 30 back to 3 or 5, for example, to make the game more challenging. Compile and save. And there you go. So the last step is to go over here inside of our Battery Man mode H, and over here we need to start spawning these batteries, because only now we have currently one in the game. We don't want that. We want more. And when I delete this, when I run the game, I want them to spawn on their own and I want to pick them up. So let's go over here inside of the Battery Man game mode H, and right here we're going to include a couple of things. So first of all, I am going to include the Battery Man. Actually, we are not. We have everything over here. So no, we're not going to include anything. So ignore that. Let's move forward. We have over here actually what we are going to create. So as you can see, the difference between our batteryman.h is that we had all of these things already implemented, such as the constructor and so on and so forth, but here we don't. So the first thing is I'm going to say a batteryman underscore game mode. This is the constructor, so game mode like this. This is our constructor. I'm also going to create here virtual void begin play. And here I'm going to say override, so open close parentheses, and I am going to say override. There you go. Now this right here, as I said, is our constructor. So this is a constructor, and let me just a batteryman game mode. This is the name of it? Yes, I believe it is. Let me just put it over here. Yeah, this is the name of our constructor. So simply type it out. There you go. So it works. This is our begin play. We're also going to have virtual void, and this is going to be our tick function. So it's virtual, there you go. Tick, which takes a float delta time. And also I'm going to say here override, because we want to override it. And now I'm going to create our U property, which is going to edit anywhere. So we're going to be able to edit it anywhere. And I'm going to use a T subclass of, and this is going to be a pawn, which is actually our pickup item. So here I'm going to say player recharge. There you go. We are also going to spawn our player, or actually the pickup. So here I'm going to say U property, and this is going to be edit. So edit anywhere like that. And this is going to be for X and Y, but for the Z here we're going to say float spawn underscore, so spawn underscore Z, it's going to be equal to 500. This is basically how high we want to spawn our player. And over here we're going to have float, and this is going to be our spawn, so spawn underscore X underscore minimum, and I'm simply going to copy this and paste it because we're going to have a maximum. And here I'm going to say max, and I am going to copy this and paste it, and this is going to be spawn Y minimum and spy Y maximum. There you go. And the last thing is we're going to have void spawn player recharge. There you go. This is going to be our function, and voila. Now don't worry about this. Edit anywhere, flaw, spawn minimum Y. Why is it minimum Y, maximum Y? What? Control Shift B. Let me just try to compile this and see. But I do believe that since we did not implement begin play and tick, this will throw an error. So let's try it out. Yes, it throws an error because we did not edit anywhere. What did I type here? Property, edit anywhere. This should be fine. Oh, it's actually U property. There you go. It's U property. I missed the U. I did not copy this correctly for some reason. I don't know why. Let's go over here in the game mode and implement everything what we need. Here we are going to include something. So this is where I missed things. We are going to include the game framework, and it's going to be actor H. There you go. Game framework actor H. And I'm going to have here a batteryman game mode, which is our constructor. There you go. And here we're going to say colon a batteryman game mode. There you go. This is our constructor. And inside of the constructor, we are going to say primary tick and B can tick, so can ever tick is going to be equal to true because we do want to tick, which is going to call the tick function every frame in a second. I'm also going to go over here and take this and say colon, and this is going to be our begin play because I want to override the begin play. And in the beginning, we need to say super colon, so colon, begin play to call the begin play function. There you go. I am also going to, so over here it's void. We do need to add void, so excuse me for that one. I forgot to add void. And lastly over here we also need to add void. It's going to be colon and our tick float delta time. And also call the super for tick. So here we're going to say super and call the tick function. So it's actually tick passing the delta time inside of it. There you go. So what are we going to do? Well, here I'm going to implement this function. So this is the function I want to implement. Right click and here create declaration definition. There you go. And here is our function. So what I'm going to do inside is I'm going to say float, and here I'm going to say random x to spawn the random value. We're going to use fmat colon rand range, and we are going to use spawn x minimum and spawn x maximum. So it's going to give us a random range between the minimum and the maximum. We're going to use the same for the y. So rand y is going to be equal to fmat colon rand range. So rand range, here we're going to say spawn y minimum. And here we're going to say spawn y maximum. And I noticed that I added x on both. So over here, I'm simply going to remove x, add y, remove x, add y. This is going to be our random y. And here, f vector, which is going to be our spawn position, that's going to be equal to f vector. And here I'm going to say random x, random y, and spawn z position. There you go. So it's actually spawn z. Spawn z, there you go. And the statement. Our f rotator, which is going to be the spawn rotation because we need that, it's going to be f rotator. Here we're going to say 0.0f, 0.0f, and 0.0f because this is the initial rotation. We don't care about the rotation, we only care about spawning the position. And here we're going to say get the world because the world is the one that's going to spawn the actor. So spawn actor. Don't worry about if you see this red line, it will work. So spawn the actor. Player recharge, spawn it at the spawn position. Make sure that you add the and sign. Make sure you add that. And sign spawn rotation. There you go. And this is our function inside of the begin play is where we are going to call the function. And basically we're simply going to copy this code over here. We're going to copy this code over here and I'm going to paste it, and here instead of battery man, we are going to call this battery man mode. This is what we are going to call. So here, pass this, and we are going to call it over a random period of time. So here I'm going to say fmat rand range, and that random range is going to be from 2 to 5, and here we are going to set to true, which means it will call this function forever. So it will repeat the calling of this function, and between every 2 and 5 seconds, it is going to call the function player or spawn player recharge. Control Shift B to make sure that I didn't do any oopsies over here. And if I didn't do any oopsies, we are practically done with the game. And yeah, build has succeeded. Yay! We do have one more thing to do, because this will throw an error if we don't do it. So let's go over here in the blueprints and the battery man mode. So over here, you see player recharge, we need to add that, which is basically our pickable item. So search here, here it is, pickable item. Spawn X minimum is gonna be negative 1600. The maximum is going to be 770. Spawn Y is gonna be negative 1290. And this is the minimum of the Y. And the maximum of the Y is going to be 1000. And make sure that you compile and save that, because already here inside of our, let me just try it out here, we set the spawn Z to be equal to 500. So that is totally fine. That is okay. We don't have to change that. But if you are wondering how do I know these values for the X minimum and maximum and so on and so forth, well, I took this pickable item and I placed it over here. Then I saw I saw the Y position over here. Then I put it over here, saw the Y position over here, put it over here, saw the X, put it over, you get the point. You get the point. So if we did everything correctly, make sure that you go over here, compile and save, and here everything has compiled. So Control-Shift-S to save everything. If I hit the play button, if we did everything correctly, we should see that our pickable, there it is, one has started to spawn already. And here is another one. I'm going to pick it up. There you go. And I have recharged. So let's pick this one up, recharge before we die. So let's try to recharge. And here is another one. So there you go. Okay, there is another one over there and we are going to die soon. So you can play with the time interval to spawn this sooner or later or whatnot, however you want to call it. Sooner or later, there is no other way how you can call it. So 10 and 10, and soon I'm going to die. There is no hope for me. And yeah, there you go, I have died. And now we're going to restart the game. So there you go. Congratulations on creating your first C++ game in Unreal Engine, and I have really enjoyed this tutorial. If you want to find out more, if you want to learn more about C++ and Unreal Engine, enroll in my academy. Link will be in the description below. I will run a discount so you can join for cheaper and afford the academy because I want you there, because you will learn. I have more C++ and Unreal Engine courses over there, which is really cool. And if I did not create a first-person shooter survival horror game with C++ already, then I will create it, or I'm in the process of creating it. Anyways, check out the Academy. Click the link below, fireherefromozdudes.com. Thank you for watching this tutorial, and I will see you guys in the next video.